Welcome to the Explainer. Today, we are cracking open the developer's toolkit for honestly one of the most popular programming languages out there, C#.
So how do you go from just a blank screen to a modern working web application? Well, it takes a pretty specific set of tools, and today, that's exactly what we're going to do. We're going to explore the C# toolkit, all the key pieces a developer needs to build something from the ground up.
All right, here's our game plan. We'll kick things off with the absolute basics, the core code. Then, we'll get into the blueprint for structuring it all. After that, we'll fire up the engine to work with data, and finally, we'll build the part you actually see, the interface. Let's dive in. Okay, first things first. You know, before you can build a house, you gotta understand your materials, right? Your wood, your nails, your concrete. For a C# developer, it's no different. And it all starts with two really fundamental ideas: where you put your data, and how you tell the computer to do something over and over again.
So every single piece of data in your app, every number, every name, every little thing, it has to live somewhere in the computer's memory. C# gives you two, let's call them neighborhoods, to choose from. You've got the stack, which is like a super organized, super fast filing cabinet, and then you've got the heap, which is more of a flexible, open plan warehouse. Believe it or not, this one choice, it affects literally everything else you're about to do.
Okay, let's really trace the domino effect here. Look at this. A simple little number, that's a value type. It goes on the fast stack. Easy. But a big, complex object, a reference type, that goes on the heap. Now look at what happens when you assign it. If you pass that number somewhere else in your code, you get a brand new copy. But with the object on the heap, you're just copying its address. It's like copying a shortcut on your desktop, not the whole file. And that is why the garbage collector only has to worry about the heap. Its job is to go around and clean up all those old objects that nobody has a shortcut to anymore. All right, so almost every single program you'll ever write needs to do things repeatedly. And for looping through, say, a list of items, C# gives you two main tools. You can think of them as a versatile, adjustable wrench versus a simple, straightforward paintbrush. Each one is perfect, but for a totally different kind of job. The for loop, that's your precision tool. It's your scalpel. You see here, it gives you an index, so you always know exactly where you are in the list. That gives you the power to skip items, go backwards, or even change the list while you're looping. Then you have the for each loop. That's your paintbrush. It's way simpler, way more readable. It just goes through every single item one by one. But, and this is super important, it won't let you change the collection while you're in the middle of using it. It's a really great safety feature, actually.
So we have our basic materials down. Now, how do we actually build something that holds together? Well, that brings us to our second section, the blueprint. In the world of programming, this is all about using something called object-oriented principles to create logical and, more importantly, reusable structures for our code.
So inheritance is this awesome concept that lets us build on work we've already done. For instance, you could define a general vehicle class, right? And then you can create a car class that just inherits everything from vehicle, because a car is a vehicle. It saves a ton of work. Now, as you can see here, C# has a rule. A class can only inherit from one parent. But, and this is really clever, it has a workaround called interfaces. An interface is like a contract. It lets your class promise it can do certain things, which basically gives you all the benefits of inheriting from multiple sources. It makes your code so flexible.
Okay, before we can see how different parts of our app communicate, we need to meet the messenger. And in C#, that messenger is called a delegate. Think about it like this. A normal variable holds a piece of data, right? Like the number 5 or the word hello. Well, a delegate variable is different. It holds a reference to an entire action, a whole method. It's basically a placeholder for a function that you can plug in later. Super powerful stuff. And this is where delegates really shine. They are the engine behind events. An event is pretty much a broadcast system. You've got one object, the publisher, that shouts, "Hey, something important just happened." Then you have other subscriber objects that are listening for that exact announcement. When they hear it, they react. It's exactly like a YouTube channel subscription. The creator, the publisher, doesn't need to know every single subscriber's name.
They just upload a video, and the system notifies everyone who's subscribed. This idea, it's called loose coupling, and it's absolutely fundamental for building modern apps.
And setting one of these up is actually a really straightforward three-step dance. First, the publisher sets up the event and defines the contract, basically the rules for how to respond. Step 2, the subscribers create methods that follow those exact rules. And finally, step 3, you just connect them. The subscribers officially sign up for the event. That's all there is to it.
So our app has a structure, it's got a blueprint, but right now it's just an empty shell. It needs data to be useful. So in this next section, we're going to look at the engine, ADO.NET. This is the standard heavy-duty framework that C# uses to build a bridge between your application and a database. Now, with ADO.NET, you basically have two main ways to go. There's the connected model, which is kind of like having a live open phone line directly to your database. It's always on, always listening. Then there's the disconnected model. This is more like getting on an airplane. You download all the movies and music you need beforehand, you enjoy them during the flight with no internet, and then you sync everything back up once you land and get a signal again.
This table really lays out the trade-offs perfectly. With the connected architecture, that connection is always active, which means you have constant network traffic, and obviously zero offline support. The disconnected model is the exact opposite. It's designed to minimize network chatter and is built from the ground up for offline use. And this choice directly points you to when you'd use each one. Simple, real-time stuff, go connected. Complex work that needs to survive a bad connection, you're going to want disconnected.
So when exactly would you use the connected model? Think about a livestock ticker on a finance website, or the bidding screen on an auction site, or maybe a real-time analytics dashboard. Anytime you need the absolute latest data, like right now, and you're pretty sure the network connection is solid, this is your go-to.
And what about the disconnected model? Well, it's all about handling complexity and being resilient. Imagine a mobile app that needs to work even when you're on a subway with a spotty connection. Or maybe an application where a user is filling out a really long, complicated form. They can take all the time in the world, make all their changes completely offline, and then, boom, you send it all back to the server in one nice, efficient batch.
All right, we've laid the foundation, we've structured the code with our blueprint, we've connected the data engine. Now it's time for the grand finale. Building the part that people will actually see and touch, the user interface. And for modern web apps, that means creating something that's both dynamic and secure.
To build those dynamic web pages in the .NET world, you're going to be using something called Razor. It's this really elegant syntax that lets you weave together standard HTML with powerful C# code. The magic really happens with that little @ symbol. The second you type it, you flip a switch, from writing HTML markup to writing actual C# logic. You can drop loops and pull in data right inside the page. It's awesome.
You ever wonder what makes modern web apps feel so fast and fluid? A lot of the time, the answer is this: AJAX. It's the key technology that lets a web page talk to the server in the background, without that clunky full-page reload we all used to hate. So every time you like a post and the counter just updates, or search results appear as you type, yep, that's AJAX right there.
And finally, and you could argue this is the most important part, we have to talk about security. This really boils down to two key ideas that sound alike but are totally different: authentication and authorization. Simply put, one asks, "Who are you?" and the other asks, "Okay, now what are you allowed to do?" Let's use this table to really nail it down. Authentication answers the question, "Who are you?" The process is that familiar login screen, username, password. Think of it like a bouncer at a club checking your ID at the front door. He just needs to know you're on the list. But only after you're authenticated, after you're inside the club, does authorization kick in. Its question is, so what can you do in here? The process is checking your role, your permissions. The bouncer lets you in, sure, but do you have the VIP wristband to get into the exclusive lounge? That second check, that's authorization.
And there you have it. We've gone from the tiniest decision about memory all the way to the architectural blueprints that shape your code. We hooked up the data engine that gives it power and built the secure interface that brings it all to life.
You've just seen the essential tools in the C# Developers Toolkit. So the only question left is, what are you going to build first?